we have studied Z transform purely from mathematical point of view. Now let's see from signals view. What is the difference? When we were understanding it from mathematical point of view, xn was simply a function for us, a mathematical function. Here xn is a signal. The treatment is same, but there is a difference of terminologies and understanding. We'll be understanding the signals also, the waves also, when we'll study Z transform for signals. Okay, so let's have a quick recap. If xn is a discrete signal, xn is a discrete signal. You understand what is discrete? So if xn is a discrete signal, what we do, we take transform of this xn, which is written like this. This is basically Z transform of xn. So Z transform of xn, which is written like this, is defined as n equal to minus infinity to plus infinity, xn the signal, into z to the power minus n. This you know. This is from minus infinity to 0 or 1, sorry, minus 1, it is the left sided n. That is, if this is n and this is 0, this is n line. So this side is called left side, which is from minus infinity to minus 1, and from 0 to this side is right side. Since it is discrete, so we don't have any value between this and this. That is why we write from minus infinity to minus 1. Okay, so this is the basic definition of Z transform. Let's see what is the relation between Z transform and discrete Fourier transform. See, maybe you haven't studied Fourier transform. If you have studied, that's good. Even if you haven't studied Fourier transform, for a signal, let's say yn, let's say the sequence is yn, the Fourier transform of yn is given as n equal to minus infinity to infinity, the signal, into e to the power j omega n. This is the definition of Fourier transform. So what we are trying to understand is relation between Z transform and Fourier transform. So we are starting with this so that there is a clear understanding. So we know Fourier transform of this, and we know Z transform of xn. We just saw it is given as n equal to minus infinity to plus infinity, xn into z minus n. These definitions are there. We have to find what is the relation between these two. Now z is a complex number that is given as r e j omega. Okay, what is the meaning of this? That if you have this, if this is z plane, this is the real axis and this is the imaginary axis, then it is basically a circle where the radius of the circle is r. This point is r. This is the meaning of this. As a complex number, you very well understand complex number. So this is this case. So if you take Z transform of xn and put the value of z, what you will get? It will be n equal to minus infinity to infinity xn, and then re, see, z to the power minus n, that is r to the power minus n, e to the power minus j omega n. Okay, I have put this value in this equation. Now if you look at this very closely, if you club these two terms and see, this is basically yn, that is Z transform of xn is nothing but Fourier transform of xn into r to the power minus n. Clear? See this equation, if you fit yn equal to this, so Z transform of xn is Fourier transform of this xn into r to the power minus n. Okay, now if r is equal to 1, what is the meaning of this? What is r? R is basically mod of z. So r equal to mod of z is r. So r equal to 1 means mod of z equal to 1. So we plotted this. So the circle here is, the radius is 1 only. 1, that is unity. This is the real part, this is the imaginary part. So r is 1. Okay, this is not perfect circle. Okay, so if r is equal to 1, that is mod of z is 1. This means Fourier transform of, see this is 1, so this is Fourier transform of xn only. That is, for r equal to 1, that is mod of z equal to 1, z transform reduces to Fourier transform. Again I am saying, for if modulus of z is 1, that is r is equal to 1, z transform of xn reduces to Fourier transform of, discrete Fourier transform of xn. This is the relation between these two. To understand here, this means at the contour, that is this r equal to 1, this is the contour, r equal to 1, that is on the z plane, on the contour of this unit circle, z transform reduces to Fourier transform. Okay, this is conceptual part. I think this is clear. Okay, next let's move to region of convergence. What is region of convergence? Now when you take xz, which is z transform of xn, you have function of z, xz is basically a function of z, so there will be range of values for which xz converges. This is a sequence, this is a function, obviously a function will converge or diverge, so there will be a range of values for which xz converges. This set of, or this range of values is called region of convergence. Okay, this is the definition. Now we'll take examples and we'll understand all these. Okay, so let's start with our first example. Our sequence is xn is a to the power n un. You must have seen this while solving z transform in mathematics also. So the sequence is xn is a to the power n un. Now let's take z transform, that is xz. It will be n equal to minus infinity to plus infinity, a to the power n un, z to the power minus n. What is the meaning of un? Un is step function, that is it is defined for n greater than 0 only, greater than equal to 0. Below this, that is n less than 0, this is 0. So this reduces to n equal to 0 to infinity. This is a n z minus n. Or what you can do, you can write it like this, a z minus 1 to the power n. What is this? This is a sequence. N equal to 0, this will be 1. You can write it at 1. Then az minus 1. Then az minus 1 square and so on. That is, this is the progression. Now if az minus 1, the ratio of progression, that is az minus 1, this is the progression. If this is less than 1, the ratio of progression is less than 1, what you get is 1 by 1 minus r, the ratio of progression. So it is this. It can also be written like z by z minus a. And what is the region of convergence from here? You know, this will be, if you take it to this side, what you will get? You will get, if it goes to this side, is a z, so z is greater than a. That is, if you plot on z plane, if this is real, this is imaginary, it is a circle, so let the radius of that circle be a, then it is greater than a. That is, the region of convergence is this, out of this region. So this is the question. Now let's see second question, second example, closely related to this question. Minus a to the power n x of minus n minus 1. What is the meaning of this? Sorry, not x of u of unit step function, u minus 1. This means if this is n, this is 0, this is minus 1. So this means this side, that is minus infinity to minus 1 to minus infinity. Okay, so our xz will be n equal to minus infinity to plus infinity minus a n u minus n minus 1 z minus n. So this can be written like, I am taking this minus out, so this will be, see, n equal to minus infinity, you understand this, it is minus infinity to minus 1 only. So that we can remove this, we will get a to the power n z minus n. Okay, so how to solve this? See how we solve this. Let's think of n as minus n, that is, let's put n equal to minus n, then this will be 1, this will be infinity. So what we'll get? We have taken n as minus n, so n will be from 1 to plus infinity, and here this will get reversed. We have taken n as minus n, so a minus n z n. So this is what we get. Now still we can't solve it. We need to have a progression from n equal to 0 to infinity. So we can write it like this: 1 minus n equal to 0 to infinity a minus n z n. Why? Because when you put n equal to 0, it is 1. So 1 minus 1 0. So this is effectively, you can write it like this, and you can write this like this: a inverse z to the power n. So what you get is 1 minus 1 by 1 minus a inverse z. This is what you get. So you can, if you take it, I'm doing it here only. So it will be 1 minus a inverse z minus 1. So this cancels. What do you get? You get, this is minus a inverse z. See, this is minus a inverse z. Yes, correct. This is minus because here it will be minus and then minus. So what we get is minus a inverse z by 1 minus a inverse z. So you can write it like this: a inverse z by a inverse z minus 1. You can simplify it, multiply by a up and down. What you will get? See, if you multiply by a, this is gone, and here you will get this. So you can simplify it. Now let's come to this point. This has to be a inverse z, the modulus has to be less than 1, so that we could calculate the progression. What is the meaning of this? This means z less than a. This means mod of z less than a. That is, the region of convergence, I'm plotting it here, the region of convergence here will be less than a. So if this is a, it is inside this. So although the function that we have got for the first one, when the sequence was a to the power n un, and the second one when it is minus a to the power n u minus n minus 1, this is same, the expression is same, but region of convergence is different. There it was out of this circle, and here it is inside this circle. Clear? Our next question is this. So xz will be, this is a to the power n un, and what we had got was a z minus 1. This was for a to the power n un. What was the result? The result was 1 minus a z1, or it was z by z minus a. This was the result. So for this we'll have, when you will put everything, you will get 7 into z by z minus a, that is 1 by 3. And we had seen it was mod of z was greater than a, that is greater than 1 by 3. A is this. So this is the region of convergence. The z is defined for these values. Now for this one, it is 6 into z by z minus 1 by 2, and this will be mod of z for greater than 1 by 2. First of all, let's understand the region of convergence. This says if you have, this is 1 by 3 and this is 1 by 2, this function says it is, the region of convergence is this, out of this, and this function says region of convergence is this, out of this only. Obviously the second function won't converge in this region, so finally the region of convergence is this only. So z, mod of z greater than half is the region of convergence for this problem. Now let's see the expression. If you multiply, it will be 7321z by 3z minus 1, and this is 12z by 2z minus 1. This is 3z minus 1, 2z minus 1. So here you will get 2z, that is 42z minus 21, sorry, this will be square. 21 to 42 is z square minus 21z. Here you will get minus 12 into 3, that is 36z square minus minus plus 12z. So you have 42 minus 36z square, that is, the value is 42 minus 36 is 6. So this is 6z square minus 21 plus 12. So it is minus 9z by 3z minus 1 into 2z minus 1. So the xz is equal to this. This is the z transform, and I have told you the region of convergence is mod of z greater than half. Now let's see this question. Xn is 1 by 3 to the power n sine pi by 4 n un. Now if you remember, sine n theta sine n theta, it is 1 by 2j e to the power j n theta minus e to the power minus j n theta. This is sine n theta. So we can write this theta is pi by 4 here. So we can write sine n pi by 4 as 1 by 2j. This is e to the power j n pi by 4 minus e j n pi by 4. Okay. So sine n pi by 4 is this. Let's see. So our xz will be, or simply let's put it inside. See, this is this into this. That is 1 by 3 to the power n into 1 by 2j. Here we have e to the power j n pi by 4 minus e minus j n pi by 4 and un. So if you take the power n, we try to fit it, it will be 1 by 2j, first part. Then this is e to the power j pi by 4 by 3 to the power n. Okay, power n minus e to the power minus j pi by 4 by 3 to the power n, 1 by 2j. Okay, so this function is this into un. So what will be the z transform? Z transform will be, you know, for any function, I'm taking first function 1 by 2j out of this. This is a to the power n un. So the value that you get is a to the power n. So that is equal to z by z minus a, where a is e to the power j pi by 4 by 3. Okay, and here what you get is minus z by z minus e to the power minus j pi by 4 by 3. So this is the function. You can consolidate this function to get xz. Clear? You can multiply these two. This is this and this. Okay, and you will get the final figure. What's important is what will be the region of convergence. See, region of convergence means this particular function a has to be this was a z minus 1. This should be less than 1. Now mod of e j pi by 4 is 1. When you take mod of e j pi by 4, you know e to the power j theta mod is equal to 1 because it is cos theta sin theta, and mod will be under root cos square theta plus sin square theta. So this will be 1. So we are left with z inverse 3 less than 1. So if you take this side change, this will be z greater than 1 by 3. Okay. If you take z to this side, this will be z equal to, z greater than, mod of z greater than 1 by 3. So this is our region of convergence, and it is same for both, because here also it will be mod of e to the power minus j by 4. Again it is 1. So z inverse by 3 greater than 1. So we have the same result. So the region of convergence here is this one. If this is 1 by 3, so region of convergence is this. Okay. Now we have 3 expressions here for xn, our fifth example. Let's see for first. Xn is del n. So for first, our xz will be n equal to minus infinity to infinity del n z minus n. Now try to understand this. Del n, you know, del n will be equal to 1 for n equal to 0 and 0 otherwise. This you know about del 1. So at n equal to 1, at n equal to 0, this will be 1. So n equal to 0, this will be z to the power 0. So this will be 1. So xz is 1. 1 means the region of convergence is entire z plane. Okay. There is no zero. There are no zeros. There are no poles. Now let's see the second one. Xz is n equal to minus infinity to infinity. This is del n minus 1, z minus 1. Sorry, not 1, minus n. What is the meaning of this? This means at n equal to 1, it is 1, otherwise 0. So at n equal to 1, this will be z minus 1. So this is 1 by z. Xz is 1 by z. This means region of convergence will be entire z plane excluding z equal to 0. Why? Because at z equal to 0, the function will be infinity. That is, it has a pole at 1 by z. When the function is infinity, that is the pole. So clear? Now let's see the third one. It says n equal to minus infinity to infinity. This is del n plus 1 z minus n. Now this will be 1 at n equal to minus 1 only. So at n equal to minus 1 this will be 1. So n equal to minus 1 this will be z. So the value is z. What will be the region of convergence? The region of convergence is again entire z plane, but the function will be infinity at z equal to infinity, that is it has a pole at z equal to infinity. So entire z plane, but it has a pole at z equal to infinity. Okay, clear? Now let's see this question. Xn is a to the power n between these values, otherwise it is 0. So what we get is the z transform is n equal to minus infinity to plus infinity. It will be xn z minus n, but the value is only between 0 to this. So this reduces to n equal to 0 to n minus 1. This is a to the power n. So this is a z inverse to the power n. Okay. This is a progression. The ratio is a z minus 1. You know the value is given as this into this to the power n by 1 minus a z inverse. This is what we get. So if you resolve it, you will get 1 by z n minus 1. This is z to the power n minus a to the power n z minus a. So this is what you get. See, the question is xn is b to the power mod of n. Now mod of n means when n is less than 0, we'll have one left hand side operation, and when n is greater than 0, we have another operation. So we can break it into two parts. When n is greater than 0. So when n is greater than 0, we can write it as b to the power n. It is un. And when n is less than 0, we can write it as b to the power minus n u minus n minus 1. This you have seen. This you understand how to break the discrete signals. This is the right side, this is the left side. Okay. This is plus this side plus this side. This is for left hand side. That is, this is n. Then from minus 1 to this side, the function is this b to the power minus n. And from 0 to this side, the function is b to the power n. This is the meaning. So we have to take z transform. We have seen z transform of a to the power n, and we have seen a to the power minus n also. So what you get is 1 by 1 minus b z inverse. This is for this, and for this it comes to minus, because the example that we took it was minus a to the power n. This is plus, so we will take minus 1 minus b inverse z inverse. So this is the function. What are the region of convergences here? First will give mod of z greater than b, and second will give mod of z less than 1 by b. This we have seen in our example. If you want to solve it, you can this into this, then you put this minus this, you can solve it. This is not very difficult. Now what's important is, I'm leaving you can take xz, the value of xz. Now what's important is the region of convergence to understand here. See, b is greater than 0, but the function will behave differently for two cases. First case, when b is greater than 1. And second case will be when b is between 0 and 1. So let's say for b greater than 1. B greater than 1, if you see, the first will give, let's say this is b. So z greater than b means this is the convergence, region of convergence for the first function. And 1 by b, obviously it will be, since b is greater than 1, 1 by b will be less than b. So let's say that circle is this. This is 1 by b. Okay. And it is less than this. That is, the region of convergence here will be this one. This one. See, the first function says z, the range of values are out of b, this circle. And second function says the range of values for z is less than this. So there is no convergence. That is, for b greater than 1, there is no region of convergence. Okay, you get this? Now let's see the second case. Second case is when the value of b is between 0 and 1. Now, between 0 and 1, 1 by b is actually greater than b numerically. So, see what happens. This will be b, and this will be 1 by b. Okay. So, the first part says z is greater than b. That is, it means this region, out of this region. Okay. And the second says less than 1 by b. That is this region. So what you get is this ring. between 1 by b and b, this is the region of convergence. It does not converge in this or out of this. This ring is the region where this converges. Okay.